Hello my dear students, good afternoon you to all and welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. You all confirmed, can you all able to hear me and you can see me? Wonderful. Now there are so many concurrent viewers, I can say hi and give thumbs up and fire emoji in the session. Today we are going to start with electrochemistry. I just want to make this electrochemistry in three parts. Part 1 and part 2 and part 3, and we are going to discuss about little concept and more multiple choice questions. So in this NEET Chemistry, most expected 1000 questions from the NEET channel, from the Infinity Lane. Hi Monica, how are you? So you are not well and middle you just took a break. Are you watching the recordings of this session? Wonderful. And in this NEET 1000 most expected questions, every day we are coming up with 30, 35, 40 questions sometimes, and these questions, if you take the 45 days, all the topics you consider, near about 1530 questions are going to be. So among these 1500 odd questions, can't you expect 45 similar model questions for the NEET examination? So in this session, expert team is joining and making all PYQs as a basis and the NCERT, and we are discussing very good multiple choice questions. So ready for that? So little bit of concept will be discussed, and after that concept we will be discussing about little questions, and you are going to have a great opportunity to have this kind of sessions. So what is the oath of the day? Simple. No great agenda, only one agenda, that is crack your NEET examination. For that, my dear students, you all join the session without any fail and take a pen and paper and solve along with me, so that I am going to give you a simple trick and solving the question solving strategies as well, and we will be discussing the concept related to the question as well, right Monica? Now please like this session, share with your friends and subscribe to Infinity Lane YouTube channel. And on the Google App Store you will be having a Infinity Lane app, and you can click it and you can download and you can have live sessions, mock test, create your own test, 24 by doubt resolution sessions, and it is feel free, and enjoy the sessions like anything. And whenever you are preparing for something, it is required to understand where exactly you stand and how do you know what you know, and what is your strength and what is your learning abilities, outcomes and all. And for that you need a proper assessment platform. In that proper assessment platform, Infinity Lane is designed all India test series pack, and it has 27 AITS examination, and you have 4 part tests, 13 unit test and 10 grant tests based on NEET pattern, and 20 online NEET full syllabus mock test, 25 NEET topic quiz, previous year questions, and 3 physics chemistry books along with video solutions on the app, and detailed solutions and performance reports for every test, and your performance is going to be benchmarked with Sri Chaitanya students. And this is quite helpful to you, and this cost is 5,999 when you apply YouTube 50 off coupon code, then only you are going to get, then you are going to get 50% off, so that you are going to get it for 2,999 on a special discount. In the description box, link is available, click it and you enjoy the seamless preparation with Infinity Lane for your NEET examination. All the best. And getting into the electrochemistry now, promotions are over. Everybody just thumbs up and fire emoji so that we can start the electrochemistry. Wonderful. Right, Monica, any doubts as far as the previous class is concerned? And use this chat box to make a transaction between you and me. You give the doubt and I am going to give the solution for that. Fine. Now in the electrochemistry, majorly I want to take this part of electrochemistry as Shivang, hello, as galvanic cell and electrolysis and electrolytic conductance and corrosion and batteries. 4 important major areas. And today's topic we are going to, there is no priorities. So these are the 4 major things, and you are going to get minimum 1 or 2 questions based on this electrochemistry chapter, and 4 marks will be in your pocket. So my intention is to talk about today's class about electrochemical cell, galvanic cell. So, and tomorrow we are going to discuss about electrolysis and electrolytic conductance, Faraday's law, Cold-Rush law, and their applications based on that numericals. And day 3 we are going to discuss about combined version of all these three, and also batteries and corrosion. Definitely take an NCERT book along with you and solve the questions along with me. So this is a training session, you can say. Don't expect a question is displayed and answer is displayed. Now we are going to discuss each and every point, so not even a single sub point is going to escape out of our conversation. So my dear students, let us start with galvanic cell. What is this? Is a galvanic cell. This galvanic cell, zinc rod is immersed in zinc sulfate, copper rod is immersed in copper sulfate, and they are connected by using a voltmeter, and they are connected by using a salt bridge. So this is a simple construction. Let us have a quick revision about what exactly the reactions are taking place. So zinc loses electron and becomes zinc 2+. This is an oxidation process. And copper takes those electrons and become a copper. So it is a reduction process. And my dear students, the electrode where oxidation takes place is called anode. So this is your anode where oxidation taking place, and this is the reduction taking place. The electrode which is taking place at reduction is a cathode, and loss of electron is an oxidation, gain of electron is a reduction. So copper mass is decreased, copper mass is increased, and zinc mass is decreased. So this is about the galvanic cell. So in this you are going to see the electrons are moving from anode to cathode, and the current is from cathode to anode. Okay, so the IUPAC representation is zinc is converted into zinc 2+, you can say zinc 2+, and the copper 2+ is converted into copper, and both are separated by salt bridge. So let us talk about the applications of this galvanic cell, right? So at standard conditions it is going to be 1.1 volt. So the spontaneous redox reactions taking place, delta G is going to be negative. One important thing, if you put a battery over here, if you put an external EMF over here, so if external EMF is equal to 1.1, external EMF is greater than 1.1, so external EMF is less than 1.1. So in these three cases what is going to happen? It's a awesome context, it is from the NCERT. If delta external EMF is 1.1 volt, what happens? The cell is producing 1.1, that is a driving force, and the external EMF is 1.1 volt. So both are going to be cancelled, and it is going to be delta G is going to be 0, and the system is said to be at equilibrium. And if external EMF is greater than 1.1 volt, so external EMF is there, and the cell potential is just 1.1. So the cell is going to be non-spontaneous, it is going to be positive, and cell works like electrolytic cell, electrolytic cell. That's very important. Okay, Monica. Now when external EMF is less than 1.1, so still the cell is going to be more dominant than the external EMF, so that delta G is going to be negative, and the cell reaction is spontaneous. Cell behave like galvanic cell, works like electrochemical cell. So this is actually explained in the NCERT itself, on the first page itself, on the electrochemistry. So let us go into the details about this electrochemistry, just formula revision and hot topics are also included in that. Okay, Bacho, any doubt as far as this slide is concerned? Any doubt as far as the slide is concerned? No? Monica, shall I move ahead? Now, if you have any doubt, you please ask us. Clear. So moving ahead for the next. Now talking about what is SRP and SOP, standard reduction potential and standard oxidation potential. Shivang, so standard oxidation potential is equal to standard reduction potential. I just want to say here E naught cell for copper 2 plus and copper is going to be plus 0.34 volts. So this is for copper 2 plus is converting into copper. So it indicates it is a reduction process. So it is called SRP value. By looking at that signal, you can say it is SRP value. So SRP value, SOP value, magnitude is same and sign is going to be absolutely reversed. So E naught value for Cu and Cu2 plus is going to be minus 0.34 volts. So copper becoming copper 2 plus is an oxidation process, so that is called standard oxidation potential. Okay. And similarly you can say E naught value for zinc 2 plus and zinc is going to be minus 0.76 volts. There is no guarantee, there is no rule like SOP values, SRP values like the positive or negative. It could be any. And if you reverse this, E naught zinc and zinc 2 plus is going to be plus 0.76 volts. It is SRP value and SOP value. And what this value is going to trying to tell you? Yes, these values is a super awesome trick. As SRP value increases, tendency to getting oxidized is increased and its reducing power is increased. That is super awesome trick. Everybody follow this, take a note on this. Shivang, Monica, fine. आगे बढ़ना थोड़ा सा, and based on this we can discuss a bit of questions. Yeah, as it's a contradictory. As SRP value increases, tendency to get reduction increases and oxidizing power increases. So definitely in the JEE mains 2025, in the previous NEET examination also, a couple of questions has been already asked based on these two logics. Everybody take a note of this. Okay, this is a super awesome trick. This is going to be a super awesome trick. Understand? Clear? Fine. Moving ahead. So this is called normal hydrogen electrode or standard hydrogen electrode. So this is a platinum loop is connected to, it is immersed in 1 molar HCl and it is connected to a gas of hydrogen at 1 atm pressure maintained at 25 degrees centigrade, and it is connected to as an electrode. So E naught of the standard hydrogen electrode is said to be 0.0. So there is a reversibility. H2 you can write this as H plus takes an electron and it become half H2 and which is 1 molar and it is 1 atm. So this E naught value for this Hu plus and H2 is said to be 0.00 volts. Mind it, it is taken as a reference. It is taken as a reference. Are you getting or not? Clear? Any doubt? Okay. One more important thing. This hydrogen electrode is connected to the other electrodes, and a series of the electrode potential table is made, that is called electrochemical series, that comes in the next slide. I want to say a metal plus an electron gives rise a metal, right? So let us say this E naught value is a minus X volts. Okay, so if you want to say M gives rise to M plus and electrons, E naught value for the reverse process is going to plus X volts, mind it. If the reaction is reversed, voltage has to be reversed. And of course, from here you can say 2M plus take 2 electron gives rise 2M. What is the E naught value? You tell me. Minus 2x होगा or minus x होगा? You only have to tell me. Shivang. So learn the things in such a logic way. It is going to be minus x volts only. Don't apply too smart like a thermodynamics. Okay, if the reaction is multiplied or divided by half, and E naught value do not change. And talking about electrochemical series, so electrochemical series, by using normal hydrogen electrode, E naught values for all the electrodes has been decided and determined and made as a table. That is what is called as activity series or electrochemical series. And you can say that electrochemical series, you can say it is increasing order or decreasing order. You can say it is in decreasing order here. So you can say fluorine takes an electron, gives rise plus 2.8, and lithium plus electron gives rise lithium and minus 3.05. Now these values are taken with reference to hydrogen. Okay, now based on these positions, you can say as moving up, oxidizing power increases, and moving down, systematically reducing power increases. So the strongest oxidizing agent in the chemistry is fluorine, and the strongest reducing agent is going to be lithium. Lithium is the strongest reducing agent in the entire periodic table. Agree with me? And let us see the applications of the electrochemical series. Ready with us? You don't have to by heart this table, but you know the algorithm of this. So here below hydrogen, lead, iron, zinc, aluminum, magnesium, lithium, there are active metals. Above hydrogen, copper, silver, iron, gold, lead are there. So they are said to be inactive metals. So that's the reason why we are going to see the applications of this. Who are the elements above the hydrogen? Who are the elements below the hydrogen? At least you should have the mere idea about that. Then you can do the best. Ready for that? We can go ahead with that applications of electrochemical series. So we can start the questions based on that. And so chemical reactivity of the metals, you can know the metal that has a high negative value of standard reduction potential, SRP value, as readily loses electrons and it is converted into cations. So that is the one. And the second one, relative strength of oxidizing agents and reducing agents. And when you move from bottom to top, oxidizing power increases, down the electrochemical series, reducing power increases, right? And oxidizing power, you can see, my dear students, oxidizing power is directly proportional to SRP value, and reducing power is directly proportional to the oxidation potential value. Okay, we already discussed this. Oxidizing power is directly proportional to standard reduction potential value. Reducing power is directly proportional to oxidation, standard oxidation potential value. You just take this super awesome trick and you can apply for your NEET examination. Fine. Okay, we'll do it, and immediately a question will come. Okay, after this, displacement of hydrogen from dilute acids by metals. In the electrochemical series, those elements, hydrogen is here, those elements below the hydrogen can react with dilute acids and liberate hydrogen, and those elements which are present in the above the hydrogen do not liberate hydrogen gas from the mineral acids. That's a very important point. Very important point. Okay? And also standard EMF of the cell you can calculate based on that. You take any two electrodes and connect it. How much voltage it can give you? It is given as standard EMF, standard cell E0 is equal to E0 of cathode minus E0 of एनोड व्हेन यू कंसिडर एसआरपी. आपको कैसा पता चलेगा? एसआरपी दिया गया, एसओपी दिया गया, and according to the NCERT and NTA standards SRP values will be given, but when it is given as something is given like this, zinc 2 plus and zinc, जो वैल्यू आता है ना, you don't by heart this value, आपका एग्जामिनेशन में दिया जाता है, and it is you can see this point, zinc 2 plus is converted into zinc, it's a reduction process, so ताकि आपको पता चलेगा it is SRP value. No, Monica, you need not have to memorize this trick. Okay, so you just go through the table, and you identify what are the kind of metals which are above and below the hydrogen. Okay, and the values will be given, and based on this value you can say minus 0.66 is going to be a smaller value. And I just want to say, when two electrodes are connected, how do I know it is an anode and a cathode? I will tell you mathematically. Bigger E0 value, SRP value, electrode behaves as cathode and vice versa. And this is a super awesome trick, beta. This is a super awesome trick. Okay, this is a super awesome trick. So let's apply this E0 value of zinc 2 plus and zinc is going to be minus 0.76 volts. E0 value of copper 2 plus and copper is going to be plus 0.34 volts. And among these two, Monica, you tell me zinc and copper, whose value is mathematically bigger value? Mathematically bigger value, you tell me? Waiting for your response, Shivang. So this is going to be the bigger value, 0.34, right? So it is acting as a cathode and it acting as an anode. E0 cell is equal to E0 of cathode, E0 of anode, right? E0 of cathode minus E0 of anode when you take SRP value. Yeah, so cathode is my plus 0.34, don't change any sign, minus 0.76 volts, and when you solve this, E naught of the cell is going to be plus 1.1 volts. Understand? Clear beta? Any doubt? Perfect, perfect. So these are the, whenever I am making a box now, is going to be the best tricks that you can experience it. Now let us say a question for you. The standard reduction potential of the following half cell reactions are given. Zinc takes 2 electron minus 0.76, chromium takes 3 electron is going to give chromium minus 0.74, and H plus become H, standard hydrogen electrode is going to be always 0, and iron 3 plus become plus 0.77. Which is the strongest reducing agent, oxidizing agent? All are SRP values. All are SRP values. So far what you learned, you just recall, you can see as reduction power value increases, okay, SRP value increases, reducing power increases. Okay, SOP value increases, reducing power increases. SRP value increases, oxidizing power increases. है ना? So use that logic and you can say what could be the answer for this. We are applying the concept that you learned, right? Yes, of course it is going to be D. Maunika is given the correct answer. Maunika is given the correct answer here, because it is the highest value, so Fe3 plus is going to be strongest oxidizing agent. Can we do one more question? Now we are into the discussion about multiple choice question. We go into the Nernst equation as well in today's class. Ready for that? Okay. Standard electrode potential M plus slash M mean to say this is SRP value of 4 metals A, B, C, D are given. A का है, B का है, C का है, D का है, respected the sequence of the deposition of metals applying potential. So this is the type of question you can expect in NEET examination. Everybody? You want to say answer? What is the answer you want to say? Come on. You want to say D again? DABC, and I want to say C. Here the one which is having highest value is going to be deposited first. Mind it. The highest SRP value is going to be deposited first. That's very important. Okay? That's the logic. Correct yourself. Next, which of the following has the least tendency to liberate hydrogen from mineral acids? If you have a textbook with you and open the textbook and electrochemical series from your NCERT textbook and refer and tell the answer. Yeah, open it What could be the answer for this question? So this class is for everybody. Use the chat box and you can discuss with us. Fine. It is going to be 1 because copper lies above the electrochemical series in the hydrogen. Okay, so copper lies here. Rest of this nickel, zinc, manganese down. Understand? That is going to be answer 1. Perfect. So you need not have to by heart it, but at least you need to know what type of elements are present above the hydrogen, below the hydrogen. Okay, anyways, regarding the standard hydrogen electrode, the incorrect statement, देख के बताओ. We already discussed this. Question is given. Question is given. Monica, when you talk about this hydrogen electrode, so this is your platinum, so hydrogen gas is pumped through it and it is kept in one molar HCl and 1 atm pressure, and it is shown here 25 degrees centigrade. These are the standard conditions. So 1 molar HCl इस्तेमाल किया. It is given 2 molar HCl इस्तेमाल करना है, गलत बात है. So that the answer for this question is going to be B. Perfect. Perfect. That is going to be perfect. Yeah, moving ahead, zinc gives H2 gas with H2SO4 and HCl, but not with HNO3. HNO3 is an oxidizing agent, bachao. So what happened? So nitrate is reduced in preference to H3O plus. So that is the answer for this. Of course, when HNO3 is added, zinc is present on the top of the hydrogen in the electrochemical series. So zinc displaces hydrogen from dilute H2SO4 and HCl. While on the other hand, HNO3 is an oxidizing agent, hydrogen is obtained in this reaction is converting into H2O. It all depends upon again the kinetics and the concentration as well. Zinc dilute HNO3 and concentrated HNO3. Concentrated HNO3 nitrogen dioxide milega. Mind it? Okay, that's a different matter. It goes into the D block and P block scenario. Now Nernst equation. Nernst equation is going to be the one for electrode potential. So electrode potential depends on temperature and depends on concentration and everything. It is independent on the size of the electrode, mind it. Okay, so concentration dependent electrode potential is explained on the basis of Nernst equation. So that electrode potential for an electrode is equal to standard electrode potential minus RT by NF ln QC or M upon M plus. So let's say here for M plus, aqueous takes N electrons and become, it is going to be M in the solid state. In this reduction potential, the common version of the Nernst equation is given in this way, and here M, N plus and M, here the standard reduction potential, and R is a gas constant, T is absolute temperature, and N is the number of electrons involved in the reaction. and F is equal to Faraday 96,500, 1 mole of electrons. The charge carried by 1 mole of electron is 96,500 coulombs, and for pure liquids and solids its value is taken as 1. Its value is taken as 1. Okay. And moving ahead, for a galvanic cell, for a single electrode potential, it is given by simplification by putting all the values. Okay. E naught for a galvanic cell. So, E cell is equal to E naught cell minus 0.0591 by N log, you can say, anode by cathode. Okay, so this is for our galvanic cell. Understand? Or you can also say E cell is equal to E naught cell minus 0.0591 by N log QC, you can say. At equilibrium, QC become Kc and E cell is going to be 0. E cell is going to be 0. Any doubts? Monica, following? Yes, fine. Equilibrium constant at Nernst equation. For this Daniel cell, zinc plus copper 2 plus gives us copper and zinc 2 plus, and E cell is given as E naught cell minus 2.303 upon NF log zinc 2 plus upon copper 2 plus. At equilibrium, what happened? E cell is going to be 0, cell is at equilibrium. Shankar Harsh, फर्स्ट टीचर को गुड आफ्टरनून बोलना है. Okay, so let's follow here. At equilibrium, E cell is going to be 0. If this is going to be 0, what happens? 0 is equal to E naught cell minus 2.303 RT by NF log zinc 2 plus by copper 2 plus. So at equilibrium, QC is equal to Kc, है ना? So you can say 0 is equal to E naught cell minus 2.303 by 2 log, this is QC and become, it is a Kc. Understand? Shankar, follow the class. And when you want to talk about log Kc, you can calculate. So by using electrochemistry, you can calculate Kc as well. You can say E naught cell is equal to 2.303 RT by 2 log Kc. How it is to 2 electrons इसमें इस्तेमाल किया. Sparkle Sol, hi guys. So any doubts? Very good. Now let's do some questions based on that as well. And that is given as E naught cell is equal to 0.0591 by 2 log Kc for any cell at equilibrium. So you can calculate equilibrium constant. Cell reaction you just joined right now, so you just watch the recording. Previously we discussed the cell reaction sabka. Okay, for you I just want to discuss this again. Okay, the various things you can have. Okay, so zinc loses electron, become zinc 2 plus, this is an oxidation because the loss of electron takes place, and here copper 2 plus takes 2 electron, become copper, and you are going to see the overall reaction is going to be zinc plus copper 2 plus gives rise copper plus zinc 2 plus. Actually this is in the solid state, aqueous state and solid state, and it is going to be aqueous state. When you write QC, you are going to write copper, which is in the solid state, zinc 2 plus, which is in the aqueous state, zinc and copper 2 plus. So what happened here? This value is taken as 1 and this value is going to be taken as 1 because they are solids. So it is going to be QC is going to be zinc 2 plus concentration upon copper 2 plus concentration. You understand? At equilibrium, sparkle. So what is the meaning of equilibrium? Arre, you watch the equilibrium recording. So at equilibrium, QC is equal to KC. The situation where the rate of forward reaction is equal to the rate of backward reaction is called as state of equilibrium. You understand? Solid you have to ignore. Solid you have to ignore, right? Fine. Very good. That's the reason why these YouTube sessions are very important. If you know well, if you don't know, you are going to learn it, right? Fine. Let's go ahead with this. Again, electrochemical cell and Gibbs free energy. Gibbs free energy is the energy that is used for the work done. So that is given as Gibbs free energy change delta G is equal to minus NF E cell. So here E cell EMF of the cell, and Maunika NF charge of N mole of electron that is passed through the electrochemical cell reaction, where F you have to say 96,500 coulombs. That is the charge carried out by a cell, charge carried out by 1 mole of electron. When every electrochemical cell should have this delta G value. Delta G value can tell you the direction of the flow, and if delta G is if delta G is 0, the system is said to be equilibrium. If delta G is greater than 0, the non-spontaneous. If delta G is less than 0, it is spontaneous. So cell works. And similarly for this, E cell is going to be 0, for this E cell is going to be positive, and for this E cell is going to be negative. So these are the various combinations you need to have. Got it, my dear students? Fine. And based on this, shall we do a question? Ready for that? Shall we do a question? Yes. Now, if this E naught cell for the given reaction has a negative value, then which of the following gives the correct relationship for the value of the delta G naught and K equilibrium? Make it answer. Make it answer. You want to say A? No. E naught is said to be negative value. है ना? So the reaction do not go further. So it is going to be delta G is greater than 1 and equilibrium is less than 1. Okay? Clear? Next, thermodynamics of the cell, and we know that delta G is equal to minus NF E naught cell, and delta S is equal to NF dE by dt, that is called temperature coefficient, and these are all the formulas. And for Gibbs free energy for the cell potential, delta G is, as we know, that minus NF E cell. If delta G naught is equal to minus NF E naught, so this is at any condition, this is the standard condition. If delta G is negative, the cell works spontaneous as a galvanic cell. If delta G is positive, the cell works non-spontaneously as electrolytic cell. If delta G is 0, the cell is at equilibrium. This is an awesome point. It is connected to thermodynamics. So mind it, NEET examination, that kind of versions are required. Fine. You all written this? Now shall we do a question? Monica? Now again the promotional slide came. NEET 2025 All India Test Series Pack. And why this promotion is given by me several times in the session. So this helps you for proper preparation for NEET examination. So that बच्चों के लिए थोड़ा सा भला करने का कोशिश कर रहा हूँ. So it is shown once again and once again. And in the chat message also, and you can see pinned messages and the description box link is given. And this test series pack is 5,999. And when you apply YouTube 50 coupon code, YouTube 50 off coupon code, you are going to get it for 2,999. It's quite affordable, and Infinity Learn want to do best for the students. You all click the link and enjoy your NEET test series pack and enjoy the seamless preparation for your NEET examination. बच्चों आगे बढ़ता हूँ थोड़ा सा, and it is going to be the reaction of H2 plus AgCl reversibly gives rise H plus and Cl minus and Hg solid occurs in the galvanic cell. So the IUPAC representation, 11,000 are watching. Shadow, really? Okay, you give the answer then. It is going to be like, option C is the correct one, and anodic reaction is written in the LHS side and the cathodic reaction written in the RHS side, and both are separated by salt bridge. It is given like this: PtH2 and HCl solution, and it is given as a salt bridge given AgCl solid plus Ag, and anodic hydrogen is oxidized and cathodic silver is reduced. Muhammad Rehan, hi, I was actually waiting for you. Okay, next, the standard electrode potential SRP values for the platinum Fe3 plus, Fe2 plus, SN4 plus, SN2 plus are given. And these values, identify these values. Okay, the reaction. So this is one value, and this is another value. Okay, and you are asked to calculate E cell for this. Rehan, you want to say answer is? You want to say the answer is? Who's that shadow? Retracted the message. Okay, it's not a Malayalam class, it is a chemistry class for the NEET preparation. So no spamming in the class, students. Want to say A? Okay, let's see here. My answer is going to be A. It's a perfect answer. Congratulations, Monica. So the answer comes to be like this. So Fe2 plus SN4 plus gives us Fe3 plus SN3 plus. So that this is going to be cathode and this is going to be anode. So cathode minus anode. How do I know it is a cathode? Because it is reducing and it is an oxidizing. Okay. Now it is going to be minus 0.62. Talking about this, adding powder of lead and iron to a solution containing 1 molar each of lead and Fe2 plus ions would result in the formation of. Okay. So this type of questions you can say, this type of questions you can solve by taking the electrochemical series printed in the textbook. Okay, in the examination you will be given the respective values, so you can assess what the actual answer is going to be. Now we can see the answer is going to be A. How it is going to be? PB will be reducing to PB, PB2 plus will reduce to PB, and Fe will be oxidized to Fe2 plus. So as have a E0 positive for this process, so for the reaction PB plus Fe2 plus is going to be more positive here. Okay. Now hence more PB and Fe2 plus ions are formed. Clear beta? Perfect. Wonderful. Monica, next question. Oxidation potential of zinc, copper, silver, hydrogen, nickel are given as these values, okay, respectively. You see these values 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? Which of the following reaction will provide maximum voltage? It's super. Voltage you have to calculate EMF is equal to cathode minus anode. Okay, cathode minus anode. You have to substitute the respective values and tell me the which has the highest positive value. Tell me. And mathematically bigger value is a cathode, mathematically smaller value is going to be anode. 4 options are given, you just do it. Now it is going to be here zinc plus 2 Ag, zinc plus 2 Ag, B is the answer. Mohammad Rehan is given the correct answer for this. Wonderful, wonderful. Mohammad Rehan are ready to solve one more question here. The position of some metals in the electrochemical series decreasing electropositive characters are given. Magnesium, aluminum, zinc, copper, silver. What will happen if copper spoon is used to stir a solution of aluminum nitrate? I think this kind of questions are more prominent in the NEET examination. Very important. Very important. Want to say B? An alloy of copper and aluminum is formed how? I don't think so. No, Monica. How it is possible? Now, surprisingly, there is no reaction because magnesium, aluminum, zinc, copper. Okay. So, copper rod is used to stir solution of aluminum. So, aluminum is more reactive than copper. There is no reaction, mind it. There is no reaction. Copper is given now. So, copper and silver का साथ हो सकता है, copper and zinc का साथ हो सकता है, zinc and aluminum का साथ हो सकता है, right? Exactly, this is very important. Now, the standard reduction electrode potentials values of A, B, C are given. A, B, C, the order of their reducing power. I think you can do it. The same model of the question we did it. Already we did it. Okay. What could be the answer for this question? Very good. You want to say D, it is D, not B. Rehan. So, more is the SRP value, more is the power to get itself reduced, or lesser is the reducing power or greater is the oxidizing power. This is a noteworthy point. It is a noteworthy point, mind it. Mohammad Rehan. Fine. One more question. So, the ocean of questions are there. Exactly. Now, the E naught value for metal 3 plus oxidation state to metal 2 plus, values for chromium, manganese, iron, cobalt are given. For which one of these metals can change in oxidation state +2 to +3? If this direction value is positive, this direction value is going to be negative. That is the logic. You want to say D, chromium? Okay, wonderful. You like these questions, Monica and Rehan? You like these questions? Yes, it is. You want to say it is option D. What Rehan is given is correct. Now, when you talk about the chromium, value is given minus 0.41 plus 0.57 plus 0.77 plus 1.9. Now, when you talk about this, more the negative value of the SRP indicates, okay, is better reducing agent, thus easily oxidized. Therefore, oxidation of chromium 2 plus to chromium 3 plus is the easiest. Super question, na? Always expect this type of super awesome questions, my dear students. One more question. E naught for the half cell reactions are zinc and iron are given. E naught for the half cell reaction, Fe 2 plus plus zinc gives us zinc 2 plus and Fe. Cathode minus anode. फटाफट करके दे जल्दी. Make it fast. Make it fast. Make it fast. You want to say B? Okay, so it is B. Monica? Now it is said to be Fe2 plus zinc. So their values are given. So their oxidation potentials or reduction potential should be opposite, and reverse it, and you are going to get this value plus 0.35. Now, one more question. An aqueous solution containing 1 mole of gold, copper 2 plus silver and lithium plus being electrolyzed by using inert electrodes. The value of standard electrode potentials are given, and with increasing voltages, the sequence of deposition of the cathode will be, what could be the order? Already this same model are done in this today's class itself. Solve it, let it be. Answer? Answer, waiting for you. Answer. Mohammad Rehan and Monica. आज आलतमाश आए नहीं. You want to say D? Okay, but it is C. How come you see lithium is deposited? Now only silver and gold and copper will be deposited at cathode. Lithium won't be deposited. Alkali metal, simple. Alkali metal won't be deposited, na? So alkali metal पे पहले hydrogen आ जाएगा ना. That is the basic logic. So my dear students, today we had a great discussion about various topics from this galvanic cell and Nernst equation and thermodynamics of the electrochemical cell. And tomorrow again we'll meet to discuss about electrolysis and Faraday's laws and conductance. So hope you like the session today. You please एक बार like button मारो and एक thumbs up and fire emoji to say bye bye. Okay, signing off, Suresh, Faculty of Chemistry from Infinity Land. We'll meet tomorrow with more stuff from the electrochemistry. Okay, God bless you all. Bye bye. See you.